Hello, in this video we are going to add some AI, simple AI, to our Connect 4 game and get it so we can play against the computer. And the way this will work is we'll make a move and then the computer will make a move if we didn't win. And it'll keep going like that, until the game's over. The computer will try to make a winning move first. If it can't, it'll try to make a blocking move, and if it can't do that, it'll try to make a random move. And after the player's dropped his or her piece, we need to disable the buttons so the player can't kind of double click on the buttons. So we have to wait for the computer to make its move, and then we'll re-enable the buttons. So we're going to have to kind of have a way to toggle the buttons on and off while the computer is making its move. And let's also talk about how the computer is going to implement trying out different moves. We're going to make a function called try checker, and what that's going to do is sort of drop a test checker into a column silently. We won't see it happen on the screen, and then the computer can evaluate the result. We'll say, okay, well, if I put a checker here, would I win? Okay, well, I should make that move. Okay, if I put the other guy's checker there, would I block a move? Okay, well, I should make that move. And if the move doesn't work, or actually in either case, if the move is good or bad, then we'll make a function called remove checker to take that test checker out, and then we'll use the drop checker function that we already have to make the real move. So we'll say, okay, if I should make that move, I'll test out that move. Okay, I should make that, but I got to remove the test checker first and then actually drop a checker. So we're going to kind of test moves and then set the board back to its state and then make the move for real. So we'll have a function called try checker to kind of put a test checker in our square, and a function called remove checker to get rid of that. So I'm going to go to the end of my file here, and let's just kind of give ourselves those functions. Let's make a function called enable buttons. This will be used for turning the buttons on and off. And let's say it takes a Boolean flag called TF for true false, and it'll turn the buttons on or off, or it'll set their enabled property to whatever that is. Turns buttons, sets properties of buttons to TF. So we can use this to turn the buttons on and off. So how do we get all the buttons and how do we turn them off? Well, or on or off. The window that we're in a form, and a form has a collection called controls of all the controls on that form. So we actually have access to a list or a control collection that we can iterate through, and we can test to see if any of those particular controls are buttons. And if they are, we will convert them to buttons and disable them. So let's use a for each loop for that. So I will type for each and hit tab twice. So for every control, we'll call it C in controls, right? So I have, inside of this form, I have a control collection called controls. So this is a collection that contains all the controls on this form. Those controls will not all be buttons, right? I've got picture boxes, I have a menu bar. They're not all buttons. So I've got to test to see if each control C is a button. I'm going to make C lowercase. That was a typo. So how do I test if it's a button? Well, I can use is and as, right? If C is a button, and then I can, well, I don't even need to cast it, right? Then I can just disable it. C.enabled equals false. No, TF. There we go. So that will enable or disable all the buttons on my form. That's it. Just loop through all the controls. If it's a button, change its enabled flag. All right, that was easy. What else have we got? We have a reset function already. Let me just make one quick change to that. Let me go find the reset function. I want to make sure that when the game is over, let's set the turn back to black. And we can, we've already done that. We can say, somewhere else, but let's just write it in again. And we're using PictureBox2 to store the image of the checker. So we'll set PictureBox2's image property to equal properties.resources dot, why did that go lowercase? Properties.resources dot dot turn black. There we go. So we'll just refresh our interface. There we go. So I just wanted to make that quick change to the reset function. And now let's write our function to test a checker, just to kind of silently drop a checker into the board. This is going to be exactly like, or almost exactly like, our drop checker function. It's going to use the same logic where we start at the bottom of the column and kind of slowly creep up, looking for an empty place. So let's write a Boolean function called tryChecker. And let's say it takes the column to drop the checker into and the color to drop into that column. So let's say it takes a, I don't know, a color code, and it takes a column. And it will return true or false if the if the column's full or something, then maybe we couldn't drop a checker in there. So that's not good. So we got to make sure that we can actually we've got room in that column for a checker. So let's make a for loop that starts at the bottom of the column and works its way up. So let's write a for loop, and we'll start off being height -1. We have to say -1 because if we're in an array that's got height things in it, the biggest index is height -1. And now we're going down, so we want to say as long as I is greater than or equal to 0, and equal to 0 because 0 is a valid index, subtract 1 from I. So this is going to kind of go from height -1, it's going to count down to 0. So let's say if we find a cell in our board in this column that is that's empty, we'll put a checker there and then break out of our loop. So let's write an if statement here. If our board at that coordinate, right? So there's our two-dimensional array syntax, and our column is our parameter, and our row is J or I. Actually, I guess we maybe J would have been a better name, just because we've been using J for our row, this whole example. So if that's empty, well then let's put a checker there. So we'll say that square is now, that cell on the board is now whatever color we dropped. Place checker. And then let's return true because we were successfully able to put a checker in that column. If we got all the way down to the end of the function, that must mean that we never returned true earlier in the function and we were not able to place a checker, so we will return false. And then we just put in my, if you hit 3 slashes, it'll do that for you automatically. Tests a checker. Or I'll say silently puts a checker in a column. Silently puts a checker into a column. And then, parameters of the color of the checker and the column. All right. I'd say that's good. Now let's write our corresponding function called remove checker, and this doesn't need to return a true false flag. It can be a void function. We're just going to assume that there's a checker to remove, and we don't care about the color. We'll just remove the first checker we found because we're just going to assume it's the one that we just dropped in there using tryChecker. So again, same thing. I'm just going to use a for loop. I guess I could. I probably want to start at the top and go down rather than go to the bottom and go up. Because I don't want to remove the bottom checker, I want to remove the top checker that I find. So I want to start at the top and go down, which means positive direction, until I find a checker. And then I want to break out of my loop. So, nope, height. Okay, so start at the top, go down my column, and if I find a checker, set that square to empty and bail out, return, or break. Either one would work. Board, sub, if that column has a checker, which means it's not empty, well, now we want to set that square to empty. And let's break, which means quit looping, break out of one level of looping. And that's it. That's it. Let's put in our, well, // removes a checker. The column to remove it from. All right, sounds good. What else have we got? So now that we have a mechanism for dropping checkers and removing checkers, let's write our function that uses those functions, that it tries to it can try to find a winning move. It says if I can find a winning move, I'll make it. If I can find a blocking move, I'll make it. So it'll take the color of the test checker to drop, and it'll return true if that would result in a winning move. Otherwise, it'll return false. So let's think about what that's going to look like. Let's write this. This will be a bool function, right? It's going to return a success flag, yes or no, whether it worked or not. And I'll call this function try win or block. And what it needs to take as a parameter is the color to try to drop. So there's sometimes, the first time the computer's trying to use this, it's trying to figure out, can I win? So it's trying to drop its own color checker. The second time it's going to try this, it's going to drop the human player's checker to see if it can find a move to block, which means if the human went there, he'd win, right? So you want to drop the human colors checker instead of the computer colors checker. So let's take in a color code for the checker to drop. And what we'll do is we'll just start from the left and work our way to the right. And we'll say, okay, if we put a checker in this column, would we win? Okay, if we would win, make that move, and we're done. So let's use a for loop here that goes across every column. And what we'll do is we'll try to drop a checker in that column. So we'll say if we try a checker in, now let's see, what color are we dropping? Color in column I. Well, then what do we need to do? Well, we need to see if we won or not. Like, was that a good move? So, and we have a function to do that, the game over function. So if we try a checker in that column and that results in the game being over, we should make that move. So to make that move, we've got to pull out the test checker that we just dropped in that column. And then we want to make that move for real. And we can do that using drop checker. So remove the test checker, add the real checker, and then we're done. Return. And what do we want to do? Return true, because that was a good outcome. That was a good move. If we didn't win, what do we need to do? We just need to remove the test checker, because otherwise we're just going to be dumping checkers into the board and it's not going to work. So if we haven't returned true, what's going to happen? We're going to exhaust all our possibilities. We're going to drop we're going to cover all the rows and say, okay, you know what? None of those moves result in us winning or blocking, so we'll return false. We'll say, you know what? We couldn't find a move to make. Couldn't find a good move. And that's it for that guy. So try to put a checker in a column. If it resulted in us winning or getting a win or a block, then remove our test checker, put in the real checker. If it didn't result in us winning, just remove the test checker. And then eventually, if we cycle through all of these and we don't find a good move, just return false. All right. That is it for our trying to win or block. So now that we've got that, right, now we're building our dependencies to the point where now we can actually make our little AI. We've got the pieces in place. So now we can actually make the function that tells the computer what to do. So we're going to make this an event handler because we're going to drive it with a timer. We'll say the player makes his or her move, and then like half a second later, the computer will make its move. So we'll give this an event handler signature so that we can call it using a timer, and we'll just call it computer move. So what we'll do is we'll stop the timer so that the computer doesn't keep dropping checkers, and then we'll see, is there a winning move we can make? No. Okay, if that didn't work, try to make a blocking move. And if that doesn't work, we'll just make a random move. And then after that, we'll set the turn back to black. So let's make a function called computer move. Computer move. And it'll take, if it's an event handler, it takes the control that generated the notification, and it takes an event args structure that contains information about the event. So when the computer is moving, let's stop the timer for one thing. Oh, we didn't add a timer. Okay. The AI function. Here's our AI, right? To the extent that you could call this AI. So we're going to need a timer. Okay, not hard to do. Let's go up to our top of our file. I'm going to hit Control Home, go up to the top of the file. Oops, I guess I had some code left over from, I guess, a previous attempt at this. So I'm going to make a timer. I'll call it timer equals new timer. There we go. And what function will timer call when it ticks? It will call computer move plus equals computer move. And let's set its interval to so timer intervals are in milliseconds. So it says the gets or sets the time in milliseconds. So let's set it to be like 500 milliseconds for half a second. And the timer will not be active by default. So we're good there. There's our timer. So now let's go work on our computer move function. So let's try to make a winning. Now that we got our timer, we have to shut it off. That was the whole point of that timer, right? Stop the timer. Don't keep dropping checkers. All right, and now what do we want to do? Let's check to see if we can win. So we'll use our try win or block function. So let's say try win or block, right? So if we can't win, so try to drop a red checker. And if we can't win or block, well, then let's try dropping, or let's try to block, right? So if we can find a way to win by dropping a red checker, do that. If we can't do that, we'll enter this if statement and do the inner part. And then, okay, so is there a move where we would win by dropping a black checker? Win or block. Then put our red checker there, because then we would block. And if that doesn't happen, make a random move. Okay, so then to do that, random r equals new random. And then let's just kind of, how are we going to do this? Well, let's just pick a random number, try to drop a checker there. If that works, remove it and drop it for real. This is a little bit inefficient, but let's use a while loop for this. We'll just say while true, and let's pick a column. Int c equals r.next width. There's a column. So let's try to drop a checker in that column. Try checker, and it takes the color and then the column, right? So red C. If that works, then remove it, and then drop the checker in column C. And then finally break. So I suppose if the entire board is full, this might go into an endless loop. So what this is doing is it's just cycling, saying, hey, I was able to pick a random column. Can I drop a checker in there? Okay, do that. If it couldn't drop the checker, it'll just keep cycling and try to find another column. And then finally, we want to re-enable our buttons and change the turn. So let's make sure we're lined up here with our, we're inside of our function. So finally, let's set the turn to black, and then put the correct image in the turn box, which is picture box 2 dot image equals properties dot resources dot turn black. There we go. And finally, enable buttons true. Turn the buttons back on. So now the player can move. I think we're good there. I just want to check one thing though. In our try winner block. Yep, we're good. We're good. Okay, so now that we've got that, let's go back to that and just take a look at what that's doing. It's saying if I can try to, if I could find a move where I would win as a red player, drop, make that move. If I couldn't, then try to find a move that I could make or where I would win by dropping a black checker. And if I can, drop my checker there to prevent the other guy from winning. Otherwise, just spin here, sit in the little while loop spinning until you can find a available column to drop a checker in. And then finally, at the very end, we want to flip the turn and enable the buttons. So now, like, we're almost done. Now we just have to wire this into our main, into our drop checker function, so that after we make a move, the computer makes a move. So let's go back to our drop checker function, and let's look at how we can integrate what we have into this program. So let's say if we drop a checker and the game is not over, then we want the computer to make a move. So let's say, I think we need to put a break in here. So don't tell the computer to move. Don't computer move if game over. And now if we move and the game is not over, then it's, I guess we could have put an else in here too. Yeah, that might have been cleaner. Okay. Otherwise, computer move now. It's time for the computer to move. So how do we do that? Well, remember we said when the computer moves, we need to disable the interface. So let's use our enable buttons for that and turn off the buttons. And then all we need to do is start our timer. Timer.start. And I think we're good there. So I'm afraid to try it. Let's give it a go and see if it works. So if the game wasn't over, now the computer goes, and then the computer's going to try to drop checkers. And okay, I'm afraid. Oh, all right, let's just do it. All right. Uh-oh. What's up? All right. So why did the computer keep dropping checkers? Let me investigate. Oh my gosh, I'm so silly. Okay, so this needs to go inside of an if statement. It just has to be the computer's turn. That's it. So if the turn is red, now the computer moves, because the computer is going to be red. Computer's going to be red in this game. So if it's red's turn, now we move. I think that's it. I think that'll fix it. Otherwise, so the computer would move, and it said, okay, the computer moved, the game wasn't over, make the computer move, right? So we just need to put a check on here that says only move if it's the computer's turn. Promising. All right, so I'm going to move now, and the computer should detect. Hang on, if I put a checker here, it won't be able to find a winning move, but it'll say, okay, I'm going to drop silently these black checkers on the board. Oh, but if I go there as a black checker, I'd win, so I should go there as a red checker for the block. You see, and it figured it out. There we go. So it actually is just a little bit smart. Uh-oh, I think it's going to win now. Ah, nuts, it will beat me. All right, but you can see, there we go. It's actually not so bad. You know what we should do, though? There is a possibility of maybe the board being full. Maybe we should implement our reset function here or something. Let me do that. All I have to do is double click on reset, and we'll just call our reset function. And that's it. Well, now we have tic-tac-toe with some kind of primitive AI going on here. Not super smart, but you know, not bad. And I will admit, it beats me more often than I would like to admit. It's kind of fun though. Oh, see, I got it in a fork. Nice, I think. Did I? All right, I'm gonna say that I did. Okay. Anyway, I like this. This is fun. All right, there it is. Connect 4 with artificial intelligence. Well, some intelligence.